Right, so we'll start off this video with some statistics. Now we get the frame all complete. I did some measurements. I don't entirely have everything that I want, but I have the vast majority of it. So our fork length is 1 foot. Our overall machine length is 4 feet. Our center of gravity with an empty frame works out to be 4 inches behind the tire, which is actually our pivot. When we're loaded. All of the counterweights that machine frame itself weighs 64 pounds empty. Our target is a 50-pound payload. One statistic that I still want to get is I want to take that entire mast assembly off, and I want to get a weight on it, and I want to get the, where its active center of gravity is, to help with some calculations. All the ballast that I had in that back box, all of the rotors, that only adds up to 34.5 pounds. And our battery is another 21.5 pounds. So, with the center of gravity so close to those tires, we'd basically have to have a ballast that's, almost the same as what's going on up front. That's not entirely cool, but I can't make it any longer. Like, it's already, I really don't want to get any longer than that, So we're just going to have to add more density to that ballast box. We're just going to have to put more weight back there. So our total height, our max height, I'll just show you the whole side so it'll focus. So our max height with it all the way extended, that very tippy top is going to be 23 inches. Normal mast height right to there is 18 inches. We have the 10-inch tires, fork width 10 inches. Anyway, I'll just freeze frame on this for a second, and you guys can extract any dimensions that you're interested in. And just one more quick calculation. So the frame 64, payload's 50, ballast 60, those two little motors there, all right, we're going to be asking them to move 175 pounds. All right, so now we're going to go into some of the electronics. To drive the motors, we have a Sabertooth 2x32. That'll basically take care of, all the hard wiring. It's what, like all the, you don't have to do any programming or anything. We just hook up like 6 wires or something. Handles all the differential drive. Makes life very easy. For the 2 linear actuators, we have a Sabertooth 2x12. This guy goes for 120, and this guy goes for 65. And then to control them, we can just plug both of those directly into our RC controller. That one can actually power our RC controller. That is all the electronics that we basically need. I might also add like a little switch to do some lights. Those won't be included in our details right now because I haven't bought them yet. So this controller is like a FlySky, just kind of cheap. It's $57. Comes with a receiver. Now I had about some of the other stuff. So the 2 actuators, the 6-inch and the 2-inch, those go for $59, $53 respectively. And then I just kind of added in some of the other expenses that I have, like the tires, the bearings. I'm guessing I'm a frame metal is $50. I bought a lot of stuff at Home Depot and like the handy lengths, which is like the worst way to buy, but it was handy. It is handy. So my total just in raw materials is about like probably $460. So it's kind of an expensive project. We'll see how as it is. Boys and the toys, right? I did find a little RC relay that I can just plug directly into there. And that will enable me to turn my lights on and off. But I'll probably put in a heavy-duty switch so I can just turn it on and off from the outside. We have some male to female jumper wires that we'll use to go between the RC receiver pins and the different control signals that would be coming in. And I also found, so we got some more electric wheelchair parts. So this is the battery leads with a fuse. And this is set up for me. Normally they're set up for like the 24-volt system. So I will be cutting the end off of that, and I have 2 of these. These went from battery to the control module itself. And for these, I really just wanted these ends as a quick disconnect from the battery, so I don't have to, if I wanted the battery out, I don't have to undo these. So basically, we're gonna, take the ends off of these and resolder them onto there. You also have to configure our saber tooth. So you can see that both of these saber tooths have a little series of dip switches there. And that tape does not come off. You're gonna set it right through that tape with a little pokey tape to make screwdriver. As each of the saber tooths come with a little manual of what the configuration settings are. And here we want to set it up for the remote control so that we can just directly plug, signal wires. Where are you? Where's the light? So there you see the 0 and 5, that's outputting power for our RC receiver, because this little guy needs juice too. So we'll hook that into there, and then the S1 and S2 are our signals for motor 1 and 2. And that will get our outputs from our channels, right? So basically we give it power and ground up here on this top one, and then all of these different channels up to 6 is where we'll be doing the signal wire. So, and I've already marked this one because I've used it before, but so the bottommost pin is going to be power, the middle pin is signal, and the far outside pin here, the third one, is going to be ground, and that's true all the way down. But this first one is where you feed it. If you've ever played with one of these, I don't know if this is old hat for a lot of people. So this is battery voltage positive, battery voltage negative, and then the 2 wires for motor 2 and the 2 wires for motor 1. So it's super simple. Battery in, motor's out, the motor doesn't spin the right way, just flip the wires. And this one is configured in exactly the same way. So I have a bunch of plastic left over. This was actually from the back of an old radio, or the body of a radio. So we get it all cut to size, and we'll hot glue pieces together, all the way around, and then we'll show you what we do with the top. So we got our box all glued up, and we got overlapping tabs in a bunch of places, and I think that'll do pretty good for us. I think we're also going to make some, terminal blocks so that we can put multiple things together. So I'm starting to work on the battery end of things. First I just clip it off, kind of this end, because that's not going to be used, and this will give us a quick disconnect. And to go into the other quick disconnect, so I started working on this. Basically, you just pry and focus. See those 2 little steel tabs right there? You just push those down and you can pull these wires out, right? And it's just, it's just that little lip that sits on there. Now, when I do these, I don't have a crimper for it. I just solder them into the cup. And I was figuring that these would just be, soldered into the cup. But no, they are crimped on. And so, I kind of played with it in a vise and trying to loosen that crimp, and it was a no-go. And I put the wires in a vise and I pulled it off, just broke the wires. So finally I drilled it. And, I drilled it and I just got solid copper all the way down. And while this will work as a cup that I can now solder onto after I cut these ends off and put the thing on there, it's kind of a lot of work. But I don't want, it'd be nicer to just solder into that cup than it would be to splice this wire onto this wire, which would be kind of a weak spot. So even though it's kind of a pain in the butt, I guess I got to go through this. It went okay. It's just more work than I was figuring. So we'll get the other wire off. We'll cut these. Solder goes on. And then we'll be to the next stage. And we hold the solder cup in the vise. Key it up with a blowtorch. Fill the cup full of solder. And then just plunge the wire in. Suppose if these got hot from too much current draw that, that solder weak enemies could pull off. So was it better to do this or to just joining 2 wires? Again, still with solder. But I don't know. And next I want some terminal blocks so that I can just try and cut a bunch of connections and screw them all down. Cut this in half and start. At a rate, those should do the trick. I'm debating whether I want to epoxy the head in. Probably overkill, probably don't need it. So you have a 40 amp fuse here, right? And, this is a 2x32, so technically this could be drawing like 64 amps. Those little motors aren't going to draw that much, and I don't want them to draw that much, and I oversize things just so they stay cool, Plus, I can use it for other stuff later. Yuck. Now, I ordered a 30 amp switch. This is only a 20 amp switch. I'm guessing that those little maker motors probably draw like 10 to 12. So I also ordered a 30 amp resettable breaker that I'm going to put in here. And for the big saber tooth, the 2x32, the way we set this was, so for the radio control, your first 2 are set by this is radio control, and then this becomes the meaning of the remainder of the switches. So we hit 3 down that way for battery, we hit 4 down that way for independent. Really, sorry, we want that one to be mixed because we're mixing the 1 and 2 channels. We kept with linear and we kept with transmitter. And at the same time, we set mixing mode to off, we set exponential to off, lithium mode to off, acceleration ramping off, auto calibrate we left on. I think that'll probably be okay. Microcontroller mode we're not using, and calibrating slow we're not using. Alright, so we've glued down hot bolt, a backing plate and a riser of wax. That way as we go screw things in, you'll have plenty of room for screw heads and your locks to stick down through. We also hot glued in some blocks of wood in each of the corners. This serves 2 purposes. One, it's, further secures our sides together. And also it's going to allow us something to drill down into and put screws down in for the top. So now we're ready to get to wiring. So we have the first part of our control box wired up. We have our power coming in, but we'll strain release so those can't tug on the wires. Come in, and we have our negative terminal block, which will be shared. And then this, we ended up having to come in straight to the switch first, just because this was too close to do that tight of a bend. And the line side was even closer. So we go to the switch, and then we come back, and I use some Super Flex for this, just because it's really easy to work with. I wish it had done that through. And then from the load side of our resettable circuit breaker, then we come back, and now we're at our positive terminal block. And the terminal blocks are mounted right through the wood and everything with 2 of these per. So those should be pretty robust. So that instance, there's like almost no room for air, and bolting these down. I've put it in. I used the drill bit and went right through the hole just to mark the spot. Took the board out, drilled all the way through. Put the pin in, held the board right where I wanted, with that pin in, and then marked that one. And then I could go ahead and drill that one with the board out. And then I could mark and drill those last 2. That way we're assured that everything is going to be right. So I didn't mount either. This is a plastic enclosure, so there's no heat wicking. They did not include an air gap. It would probably be better if these were mounted to, something that was more of a heat sink, like a metal case or something, or at least an air gap. Both of these are quite oversized for what I'm doing, so I'm a monitor, and if I have to space these up a little bit more, I will. I'll just kind of run it for a while, feel how far up these get, see if it's going to be a problem. The machine will tell you. So each of the driver boards now has power and ground, and I use the Superflex. These ones were actually a little bit, they had to squish them and then shape more of it to get them in there. Also, you can see that this wire is just a little bit too long, but I don't want to waste any more ends by fixing it. probably, I mean, getting just the right lathe wire is not always that easy, but it'd probably be easier to, now I drilled the hole position trace first, and it probably would have been better off and to, start with one, create my wire at about the right weight that I want, and then drill the hole to suit the wire length. I think that'd be more accurate. Same thing for this block. Like, this is just a little bit, like, this could have been just a tad shorter. So, I could have just moved the block over and mounted it. Will it be easier in the future? Right, so I've drilled some excess holes and some zip tie strain relief. I'm not going to use quick connectors on any of these. I'm just going to, go right to the screw terminals. And I've left enough room that I can get through with my terminal. And in terms of, I decided I'm going to throw this in, even if I don't use it right away. It'll just be, easier to mount it now while I'm here. So I took a block of plastic and I just kind of relieved it for any of these protrusions, any of the through hole stuff. And I still have enough meat that I can use a couple plastic screws to secure it down. That way, all of that will be all mounted. And then for the last thing that I'm going to do, and then we're ready to, well, all right. So this will get hot glued down, well, not directly. I'll hot glue Velcro onto this and hot glue Velcro here. So that way we have a real strong mount that we can still remove it if we ever want to use the controller and something else. So I'm going to get these components mounted and then we'll do the receiver wiring. So we reused a little bit of Velcro and it's pretty shady. And it's stuck on there. It's just all wiggly. 3M makes this pretty awesome stuff. I think it's called like Dual Lock or something. They use it on the Easy Pass. It's great stuff. I have some. I just have no idea where it is. So I'll replace that eventually. All right. So now we're going to, first we'll power our receiver off of our Sabertooth. You can see on here, there's the 0 and 5 volt. So those will go into our power. Then we'll take channel 1 and 2 signal wires, which is the center. And you can see I have these marked, right? I already described it. So we'll get those 4 wired up, and then we'll do the same thing over here. Now this one was already hooked up for, all we gotta do is plug these into channel 3 and 4. And then we'll wire that, and we're basically, like electronic box will be done. All right, there we have it. We have the power and the ground for our receiver. Those come into our last connection here, and the power on the bottom, the ground on the top. And then we have signals 1 and 2, the signal wires going to channels 1 and 2 center pins. Channels 3 and 4 are going to be to our, mast and elevation. Mast angle and elevation. So those ones had the full RC signals, so we just plugged those in directly with the ground down the top. And then for our channel 5, we just have our modified adapter going over to our RC relay. And I haven't, so if we power anything off of the RC relay, which I don't have any lights right now, so I'm not going to bother doing it. All right, so we got everything wired and got our extensions on. We got an idea of our initial cable guy. I kind of twined that down so it's not going to fit anywhere. We're plugged in, we're on, and we got nothing. It's not responsive right now. So the first thing we did was, first we checked our DC voltage here, and we're indeed getting our 12 volts there. The next thing I looked at was my 5 volt power and ground for my receiver, and this is outputting a good signal. So then I tested the wires themselves, and the wires are good. And then, so something's wrong on my receiver right now. I think there's supposed to be an LED light that's on. No, it's powered. So I have some extra for my snowblower one. So I guess I'm gonna go rebind my other controller and see if I can use a different receiver. Damn it, best laid plans. Just when you want it to work. Alright, so we came up and we hooked it up to the bench power supply, and you know, now we gather with the horses, and back on the throne, and it's but I'm a moron. And some of you were probably yelling at your monitors before, like, no, 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 Gabe, that's wrong. And you would have been correct. So my, so signal is indeed but and my sloppy marking with the nail polish, the center is the positive and the bottom is the ground. And luckily, you know, I was doing it. I was misreading my markings. So I'm going to trim those up a little bit, make them a little more precise with an X-Acto, so that doesn't happen again. And we're back on track. All right, so a couple other common configuration problems that you can have when you do something like this. When we were powering it up, and so I wanted my up stick to control my vertical, and I wanted my left and right to do my, you know, angle. They were backwards. So the easiest thing to do was just to switch the channel wires into the receiver. You know, that took care of that. But another common problem that you're going to run into is, like, my relay wasn't doing anything whatsoever. You know, I had it into my channel 5. So when I looked into my controller setup, you know, my switch D was the one that I wanted, but actually I tried them all and none of them were working. So you have to, you know, go in here and specifically set which switch you want to operate a specific channel. Then my channel 6 was actually set kind of switch D, so I just had to switch those around. What was the other one? There was one more. Oh yeah. So when I turn on my controller, come on, it starts yelling at me as if, like, all my switches have to be in the down position, including the throttle. Now, when I go to power this on, so now my down stick is doing nothing, and my up stick is going the wrong way. What's going on there, right? So the trick is when the receiver comes on, it expects your sticks to be centered, and that's where it reads the signal. So after I turn my receiver on, I have to come to here and set my stick in the middle, and then I can set it on. And now when I go up, and they're actually backwards right now, down is up and up is down. So there's 2 ways to solve that problem. I can either switch the wires, or I can go in here and set it to a reverse, set that channel to reverse. And in terms of, you know, that weird stick thing where if it's, I'll go here. So now it's going to read it. So now it's reading my down stick as center. So the 2 ways to solve that. One is I can either always just turn this on first with that down, and then center, and then turn that on, which, you know, somebody else isn't necessarily going to know, and it's kind of hard to explain. The other thing is, I know on the 2x32 that I can set a mode. There's one of the dip switch things is to always just take center as a reasonable default instead of rigging it from the RC receiver. So I'm going to see if the smaller one has that setting as well and set it on the dip switches. If it does, that'll take care of it. And in terms of my motor controls right now, I'm still getting nothing. So I got to feel a little bit more troubleshooting. Maybe my dip switches aren't set quite right. You know, none of my lights are on, not even an error code. I don't think that the way I had it rigged up before, I checked the spec sheet, and these are able to handle 0 to 5 volts. So even with this, even the way this had been miswired, it never would have exceeded the bounds of those. So I either have a dead one or my dip switches are set wrong. So I'm going to play around with that a little bit, and we'll see what I'm here with. When you wire these things up, it's not all, you know, doesn't always work the first time. You got to go through and fuss with things. So just expect that. All right. So we're past out our first bit. There is our 50-pound, and it will go up. It's 3 way with these Cool. That winter actuator sounds a little rough. You definitely abused with the old snow lord. I had a part, put the clip on and replaced it. Never replaced it. All right, so it's a little bit slow on the uptake, but not bad. Vascade is really good. And in terms of, there was a setting on the small saber tooth. It was called auto calibrate mode. So switch 5, we just had to disable switch 5, and now we don't have to worry about it. It'll automatically use the same default for stick position. Now, the bigger saber tooth is jacked. It has an intermittent problem, and so see how this one has the power light on? That one should always have a power light onto the board. So the voltage regulating side that powers the thing, the receiver, that part's functional. But this is not, and it's not like a power issue because we have steady power going out. And I've wiggled a bunch of components and I tried a bunch of stuff and I seated all the switches and I didn't have it come on for a while. When I just kept kind of playing with it, I just decided to, that'll come on. And I was able to drive this thing around till like, a minute or something, and then it died, and then it would start back up. So that saber tooth is jacked, and it's brand spanking new. I mean, a year and a half old sitting in a box, but still brand new. Now, the speed on the motors was good. We had plenty of power even with the load. Another thing I'm going to do is I'm going to put the scale under that back tire with the 50-pound load up to see how much weight we have on that. I don't know if we can see it, but let's see. I'll put that, all right, almost to the ground. You can probably watch the rear tire load up a little bit. You might be able to see it. It gets slightly tippy, but it wasn't bad. Like even when I took off, it never did a little bit of a wheelie back there. So it seems like those motors are probably going to be okay. This one has too much play in it. Like I gotta get that a little bit tighter. It was a little sloppy. It didn't really hurt, but it just was sloppy. So we're going to see what we can do. I'm going to have to contact the manufacturer. I'm going to have to contact Dimension Engineering on that and see if they have any advice or if they'll replace it. I know it's been a long time, but I mean, literally it just came out of the box. So, or I might have to order a new one. I really don't need the 32 amp. So these motors are rated at 6 amps each. So I could probably get away with ordering another 2x12 for $70 instead of the 130. Crapola. I figured it out. I'm kind of a moron again. Actually, I wouldn't have expected this. This was a weird one. So the problem was this saber tooth. I mean, this automatically has the the power in the ground going right to it, right? And so this saber tooth is what's powering the receiver. And this saber tooth was when I hooked the 5 volts to the... So apparently the receiver can be powered by any of the power and ground pins, and it'll power the entire receiver. I thought that those, all of these would just be intake only to power an external device. But it turns out that this saber tooth is powering the entire receiver. And once I removed the 5-volt power into, what's supposed to be the battery where you're supposed to power this, next thing it's on and it's happy. So it was just shut down because it was, voltage thing. So now you get to see it in action. I'm going to remove the car and go outside, give you a proper show.